Hi everyone and welcome to my tech channel. In this video we will revisit the Hello World example, but we'll look at the outputs and what's going on behind the scenes, as well as how to troubleshoot problems. The first thing we notice when we run the build is that some symlinks gets created in our workspace. The first one being Bazel dash and then the name of our workspace. Then we have the Bazel bin, Bazel out, and Bazel test log. So the Bazel bin contains the outputs of our build, and that is all of the resulting binaries, including the dependencies, like in the case of our Hello World program, the greeter library. In fact, much like CMake, Bazel is able to define what action needs to be performed first according to the build dependencies, and all of those build products end up in the Bazel bin folder. The Bazel out folder is a couple of levels above the Bazel bin folder. So Bazel bin is included in the Bazel out folder. And if we take a closer look at the Bazel bin symlink, we see that this points to my Bazel cache on my local file system. Similarly, the Bazel out points also at somewhere in just a couple of folders above the Bazel bin symlink. So it's the same base path, but we're going a little bit deeper in this case. The symlink containing the name of your workspace is just one directory above the Bazel out folder, so it's also like a parent directory. Looking directly at our cache, we will find an exec root folder, and this is also an interesting directory to talk about. This is where Bazel actually executes the commands like GDB or stuff like that, as we will see a little bit later. The intermediary results that are not explicitly declared as outputs typically get deleted by Bazel once the build is done, unless we use the --sandbox underscore debug argument to our Bazel build command. In this case, Bazel will keep the sandbox, which is the directory in which the intermediary results are put. This can be useful for debugging purposes. Notice one thing here is we see that the target is already up to date. This means that Bazel looked at the state of our build, and there was no change to our source code, so it decided not to build anything, and there was no action to perform here, so that won't be as interesting. In order to build from a clean slate, we will use the Bazel clean command, and if we want to be even more thorough and remove all of the previous build results, we will run it with the argument --expunge. One thing we'll notice is all of the symlinks have been removed from our workspace. Now, if we build again with the --sandbox debug, the output will be much more interesting. As we can see, many actions were performed. One of the items I often find myself looking for is the working directory in which a particular action was performed. If I'm trying to debug why an action is failing, I will be looking for the name of the action. So as we can see, this is during compilation, and the working directory is another very interesting element. Say we are trying to find out why it's not seeing some particular files when we get some file missing issues. Every action performed by Bazel during the build will produce a similar output. For example, if we get down here, we see the linking phase where it's linking the hello binary, and we can also see what working directory it was using at this time. Every action is performed in a different sandbox, and if we go back up a little bit, we will find the working directory that Bazel used while building the hello.cpp file. And every sandbox directory possesses a number. Another thing that can be useful for debugging is to be able to see the command issued by Bazel. Bazel is nothing but a wrapper, so it'll call tools like GCC, and sometimes we want to see the exact command called by Bazel. For that, we need a failure, so I'll create a failure. I'll just remove a semicolon so we can see how the output looks when Bazel fails to build. So if I don't have any options, I'll get the compiler output, so I'll get the compiler errors and warnings, but I cannot see the full command that was run by Bazel. Sometimes I'm missing, say, dependencies, or Bazel cannot find some libraries and I want to look at the iSystem, for instance, arguments that Bazel issued to GCC. But the command itself is truncated here, so we can see the ellipsis here where Bazel is truncating the command and the output. In order to have the full command, I'll use the verbose failures option. By using the verbose failure, I get access to the full command issued by Bazel, including the CD to the working directory and the entire GCC command here. So that's really helpful when times comes to if we're facing some some issues that are more difficult to troubleshoot. And that concludes it for this video. If you liked it, don't forget to like and subscribe. Thank you for watching.